welcome to the subject software engineering. We are in chapter number 12, that is performing user interface design. In this chapter we have gone through the introductory part of it, and now this is the second lecture of this chapter. So the topic is the golden rules. The golden rules. The three important principles guide the design of effective user interfaces. 1. Place the user in control. 2. Reduce the user's memory load. And 3. Make the interface consistent. To achieve an interface that abides by these principles, an organized design process must be conducted. Students, you very well know the users interact with the system through the interface. So that is why interface must be very easy for the user to use. Okay. So first we'll consider any user would like to have his own interface control, so that he should be able to control the interface and get the activity done. First, place the user in control. 1. User want a system that meets their needs and help them get the things done. Point number 2. User wants to control the computer system and not have computer or system control them. Point number 3. Most of the interface constraints and restrictions that are imposed by a designer are intended to simplify the mode of interaction. Students, you very well know user wants that he should be able to control the system and not system should control him. As well, they want easy or simple mode of interaction. Point number 4. The designer may introduce constraints and limitations to simplify the implementation of the interface. So designer can put constraints or some limitation so that interface implementation is easy. Point number 5. The result may be an interface easy to build but frustrating to use. See, the interface is for the user and not for the developer. So many times developer would design a good interface, but that will lead to frustration of the user. That should be avoided. The design principles that allow the user to maintain the control are: 1. Define interaction mode in a way that does not force a user into unnecessary or undesired actions. For example, an interaction mode is the current state of interface. For example, if a spell check is selected in a word processor menu, the software moves to a spell checking mode. There is no reason to force the user to remain in spell checking mode if the user desires to make small text edit along the way. The user should be able to enter and exit the mode with little or no efforts. Second point, provide for flexible interaction. Because different users have different interaction preferences, choices should be provided to them. For example, software might allow a user to interact via a keyboard commands or mouse movements or voice recognition commands. But every action may not suit everyone. Consider, for example, there is difficulty in using keyboard commands okay, or voice input if you want to draw a complex shape. Point number 3. Allow user interaction to be interpretable and undoable. Students, even when involved in a sequence of actions, the user should be able to interrupt the sequence to do something else without losing the work that had been done. The user should also be able to undo any action. Point number 4. Streamline interaction as skills level advance and allow the interaction to be customized. Students, users often find that they perform the same sequence of interactions repeatedly. It is worthwhile to design a macro mechanism that enables an advanced user to customize the interface to facilitate interaction. Students, macro key commands are very useful in repetitive actions. Point number 5. Hide technical internals from the casual user. Students, casual users do not have much awareness about how the system works, so you should avoid technical internals such as operating system commands, file management functions, and other computing technology. Point number 6. Design for direct interaction with objects that appear on the screen. Students, you very well know, user would like to feel as if he is performing it. So many times he may wants to make some changes, okay, that should be made possible. For example, if there is a small rectangle, he would like to increase the area of that rectangle. So if such a facility is available, user would be happy. We'll go to next point. Okay, reduce the user's memory load. Point number 1. The more a user has to remember, the more error-prone interaction with the system will be. Students, users are not well versed. So if you allow them, okay, if they are asked to remember, they may give wrong inputs. Point number 2. It is for this reason that a well-designed user interface does not tax users' memory. Point number 3. Whenever possible, the system should remember pertinent information and assist the user with an interaction scenario that assists the recall. Students, you should see that user is always at ease, okay? You should not tax him to remember something. If you can give, you should be able to give him some clues and readily information available, okay? And some choices should be made available to him. The design principles that enable an interface to reduce the user's memory load are: 1. Reduce the demand on short-term memory. For example, students, when the users are involved in a complex task, the demand on short-term memory can be significant. The interface should be designed to reduce the requirement to remember past actions and results. This can be accomplished by providing visual cues that enable a user to recognize past actions rather than having to recall them. Point number 2. Establish meaningful defaults. Students, for example, the initial set of defaults should make sense for the average user, but a user should be able to specify individual preferences. However, a reset option should be available, enabling the redefinition of original default values. Point number 3. Define shortcuts that are intuitive. Students, mnemonics are used to accomplish a system function. For example, Alt P to invoke and print function is always used. The mnemonic should be tied to an action so that it is easy to remember. For example, when you say Alt P for printing, the first letter of printing is taken, so P. So always the first letter of task should be invoked. Point number 4. The visual layout of the interface should be based on the real world metaphor. Students, you very well know the whatever visual screen is said, that should resemble the reality. For example, a bill payment system should use checkbox and check register metaphor to guide the user through the billing process. This enables the user to rely on well understood visual cues rather than memorizing an interaction sequence. And the last point, disclose. Point number 5, disclose information in a progressive fashion. Students, you very well know, okay, if the information is disclosed in progressive fashion, user will be easy to handle. For example, it is mostly practiced in menu driven interfaces. The third point, make the interface consistent. The interface should present and acquire information in a consistent fashion. This implies 1. All visual information is organized according to design rules that are maintained throughout all screen displays. Students, okay, the information should be retained, okay, and the most of the screen should resemble, okay, whatever is the model screen. Point number 2, input mechanisms are constrained to a limited set that is used consistently throughout the application. Many times input mechanism should be very simple to use, and you can put some constraints and limitations so that consistency is ensured. Point number 3, mechanism for navigating from task to task are consistently defined and implemented. It should be easy to navigate. So the design principles that make the interface consistent are, there are 3 main principles. Allow the user to put the current task into meaningful context. Students, you very well know that, okay, many interfaces implement complex layers of interaction with dozens of screen images. It is important to provide indicators, for example, window titles, graphical icons, consistent color coding, etc., that enable the user to know the context of the work in hand. In addition, the user should be able to determine where he has come from and what alternative exists for a transition to new task. Point number 2, maintain consistency across family of applications. Student, consistency should be maintained in a family of applications. For example, a set of applications or products should all implement the same design rules so that consistency is maintained for all interactions. And finally, the third point, if past interactive models have created user expectations, do not make changes unless there is compelling reasons to do. So whatever past ones actions are there, maintain them. For example, once a particular interactive sequence has become a de facto standard, for example, Alt S to save the file, okay, you should not make changes, okay, and you should not use Alt S for some other purpose such as scaling. Students, the interface design principles discussed provide with the basic guidance. In the sections that follow, we shall learn about the interface design process itself. Students, till now we have just understood the golden rules for the interface design. Actual interface design will be taken in the next topics. Thank you.